Okay, more problems from 9.1. This is number 33, and again, we're going to find out what happens, integrate both sides of this equation, and then get some new data here, a new function, and its expansion. This is the expansion we have. This is from number 23. This was the function 2 over x minus 1, and that was actually this expanded out, and that was the general term. So again, using the technique that I mentioned, I'm just going to integrate both sides. But what I have here is I do have the chain rule up here on the top. Now the bottoms are numerical terms, so that's not a problem. They're all kind of taken into this, under the umbrella of this negative 1/2 to the n. Again, this is all just writing down, and this is just rewrites. But again, I'm going to have this binomial, so I'm going to have to use U substitution for this. Okay, now we can put this 2 in front, and we've got 2, and this is just going to be the natural log of x minus 1. And if I take the derivative of this, that derivative of the natural log of x minus 1 is 1 over x minus 1, and then if I got a 2 in front there, it works. So always check these things by taking the derivative. And then after I make my substitution, every time I say x minus 3, I put a u. And then I take the antiderivative, so I put a u there. A u squared over two. Now I have a 2 in here in the original, and then another 2 from adding that. I divide by 2. Okay, and then I add 1 and I divide by 3, and I add 1 and 4 and I divide by 4, and these numbers are coming from the original 1/2 raised to the nth power. So if you can see that. Okay? And I wrote enough steps here, so I think if you just kind of, look at these for a while, just pause, follow the work, I think you'll see where these numbers are coming from, okay? A lot of it's coming from remember the original expansion's got the 2, 4, and 8, so there's a 2, 4, and 8, and these 2's are coming from the antiderivative process. Okay? Add 1 to that, you get 2 divided by that. Add 1 to that, you get 3 divided by that. Okay, so I hope all that makes sense. Okay? And then we can do our general term. So this is going to stay the same. And then I'm going to add 1 to the u and divide by that. Okay? And end up with this. And then I can just rewrite it 2 times the natural log of x, the absolute value of x minus 1. And then you may not see these absolute value bars because look where x is. X is in this range. So if x is greater than 1 and less than 5, then this is always going to be positive anyway, so you're in good shape. So because of that interval, you may not see the absolute value bars. You may just see parentheses. That's fine. Because as long as x is greater than 1, this would be greater than 0, so be positive. And then we've got the 1/2. And these are pretty much always, these are redundant always. This is the final wrap with the summation to make sure that you've got the right index. And that should work all right. And then if you take the derivative, of this, you'll get the left, and you take the derivative of this, you'll get 1. The derivative of this, you'll get 2 times x minus 3 over the 2 times 2, so one pair of 2's are cancelled, you get over the 2. So you can always take the derivative of the left and right, make sure they check out. Okay. Now number 34 is the hardest because we do have to use U substitution, and we do have a little more complicated substitution. And okay, so we have f of x equals negative 6 over x minus 3, and etc. This was the expansion we got. This was from problem number 24. We did that work. This is the way it was given. So now I'll take the integral of both sides because I want to integrate term by term. So this is what we have, and then again, this is going to be kind of a mess here, so I have to have U substitution. So watch what happens. If this is u, if I let x minus 1 over 2 be u, then du equals 1/2 dx, so dx equals 2 du. So I'm using all the formal steps of U substitution. So when I put this in, this would be 3 plus 3 times u squared, So see what happens. 3u squared, 3u cubed. Well, it looks okay, except I have this 2 over here from the du, because I had some chain rule involvement over there. So then if I multiply everything by 2, now I've got all these 6's. So you might wonder where the 6's come from. Well, that's where it comes from. So then once we have the u substitution set up, over here this is not too bad. This, again, if we look at this, this is just going to be like 1 over x minus 3. The antiderivative of that is the natural log of x minus 3, and then we've got a negative 6 in front. So that's not a problem. And then I'll take this 2 and I'll multiply times all these terms. So all these 3's become 6's now. Okay. And then the antiderivative of now this is going to be my u, so 6u, 6u squared over 2, 6u cubed over 3, 6u to the 4th over 4, etc. Now you can simplify these out, but I just like to leave them in that form because they match the general form a lot better. 6u to the n plus 1 over n plus 1. Okay? Alright, then finally I substitute back in. So every time I see a u, I put what I had up here, let u equal x minus 1 over 2. So every time I see u, I put that. I should be ready to do a wrap here. Wrap it up. So instead of u, I put x minus 1 over 2, x minus 1 over 2, x minus 1 over 2, etc. And this is my general term, so I'm in good shape. And this is my final answer. Negative 6 times the natural log of x minus 3, so this is a new function. It equals this expansion in general. The sum from n equals 0 to infinity of 6 over n plus 1 times, in parentheses, x minus 1 over 2 to the n plus 1 power, and this is the interval of convergence. Okay. And now you can always check this by taking the derivative of each side. So if I take the derivative of this, it's going to be 1 over x minus 3 with a negative 6, so that looks like what I had up at the beginning. And then if I take the derivative of all these, am I going to get what I had at the beginning? Well, if I take the derivative of this first one, this is going to be 1/2 times 6, which is 3, so that makes sense. We'll go way back up here if I started up with 3. I take the derivative of the second one. Okay, that's going to be 3. And then I'm going to have a 3, and then I'll have the, if I take the derivative, that's going to be 2 times 6 is 12, divided by 2 is 6, then times, and if I take the derivative, that's going to be 1/2. So 1/2 times 6 is 3, so I get the 3's. All right? So you take my word for it, if you take the derivative of each of these, you'll get the original function up on top, the right-hand side of the expansion. So it does indeed work, okay? But I made a little note here. What you can do is you can check that, and then it's going to be on this same interval of convergence, the interval. All right? And I said check by taking the derivative of each side and seeing if we get what we started out with at the very, very top. Okay? And then don't forget the chain rule, because this is a little tricky because of the chain rule. Okay, I hope those help.